translating exponential function. So they've given us a whole bunch of parameters for translating an exponential function, and this is the exponential function they want us to translate. Really, the first thing we'd probably want to do is to graph this function, but we'll read through our parameters. A vertical stretch by a factor of 2, a horizontal compression by a factor of 2, horizontal shift 3 units left, vertical shift 1 unit down, and reflection on the x-axis. Okay, if we have, and we'll use this function here, we'll kind of write this out, our pair function, f at x is equal to, and there's usually a, we'll still use the 2, in brackets, you'll have I believe you guys have k, and then x minus, is it c what you guys use? D squared, darn, not squared. I'm going to move this other stuff down a little. There we go. And plus c.
Yep.
What color do I have left? I don't have one, so we'll use black. Okay, plus c. So we can quickly talk about what each of these letters do, and then maybe what we'll do is figure out which of these parameters refers to which letter in our function. The A and the C deal with vertical. Okay, everything is vertical about them. The A will deal with a vertical stretch or compression. Okay, and it also deals with a reflection on the x-axis. Does that make sense to you? Yeah? Okay. Our C will deal with vertical shifts, so either up or down. Our K deals with horizontal stretches or compressions and reflections on y-axis, and I'm running out of room here. And our D deals with horizontal shifts, so either left or right. Okay? So with that being the case, whether they want us to build the equation or just graph it, we can have an idea of how to set up this equation. So some of the things we're going to look at. A vertical stretch by a factor of 2. Well, vertical stretches, they fall under the A category. So we know that this is going to be dealt with our A. A horizontal compression. Horizontal compressions or stretches deal with the K value. So we know that this is essentially a K value. Horizontal shift 3 units. Horizontal shifts deal with our D value. And a vertical shift downwards. Vertical shifts are C. And finally, a reflection on the x-axis. Well, if we look at our little rules here, and they aren't written so nicely, but the x-axis reflections are, again, our A value. So quickly, we can already see what numbers are going to refer to what letters. And we could, in this case, possibly just build our equation this way and then fill it in using a table of values. We could also use mapping notation, or we can graph it and then just go through each of these parameters. So maybe we'll try to talk about all 3 of these. The first thing I'll do is I'm going to build our equation way down here below again. Okay, so we had f at x, and we said that it's going to be a vertical stretch by a factor of 2. So our A value is going to be 2. Along with it being a reflection on the x-axis, that means it's essentially going to be a negative A value. So our A value is going to be, oops, make sure I get an equal sign, negative 2. Okay, and that's going to be multiplied by our 2 to the power of, okay, and I'll kind of leave spaces for everything here. And our next value is our K. The only thing referring to our K was a horizontal compression of 2. Okay, so horizontal compressions and vertical stretches, we should actually talk about that before I start writing those in. Vertical stretches are when the absolute value of A is greater than 1. And compressions vertically are when the absolute value of A is between, whoops, 0 and 1. So let me fix that. Get that out of here. I'm looking for one value. That's it. Okay. And we should talk about this would be a stretch. This will be a compression. If we're talking about our K values, do you know what K values are? Stretches?
The opposite?
The opposite, exactly. It's when the K value or the absolute value of the K value is between 0 and 1. And compressions are when the absolute value of the K value is greater than 1. Okay? So they gave us the word, and I should have said that before our A. They said it was a compression. Okay, so what that means, if this is a compression, that means, again, it's going to be greater than 1. So we're looking at a 2 value. Had it been a stretch, and they were saying it was being stretched by a factor of 2, we would essentially be dividing by 2, or another way to say dividing is by multiplying by 1 over 2. Okay, so if you're dividing by 2 or 3 or 4, it's the same as multiplying by 1 by that value, so 1 over k in this case. Okay, and both of these happen to be full value of our whole natural numbers. Next one is our horizontal shift by 3 units, left. Okay, horizontal shifts to the left is actually the opposite idea. So left is a negative direction. That means we're actually looking for a positive direction. So a positive direction of 3. And finally, a vertical shift 1 unit down. Those are intuitive. So it would mean a negative going downward. So this is essentially our equation here. And we can plug it all in this way. But before we do that, I actually want to graph this. And maybe we can graph this using a quick table of values here. Okay, we'll start at -4 and kind of go by 2s. Okay, -4, -2, 0, 2, and 4. Okay, and essentially what we're doing is we're plugging in these numbers for our x here. So if 4 is to the power of -2, well, we'll have to kind of figure out what 2 to the power of 4 is. And I can quickly do that. 2 by 2 is 4, 8, 16. Okay, so I know it's 16, but because this is -4, the way we would think of it as 1 over 2 to the power of +4, which means we're equating to 1 over 16, so 1/16. Does that idea make sense? Yeah? Okay. So we have 1/16. Okay. Anytime it's a negative, we're going to be using fractions. 2 to the power of 2 we know is 4, but because it's negative, it's going to be 1 over 4. 2 to the power of 0, any exponent to the power of 0 is 1. And then these are essentially the reciprocal values of our y. So 2 to the power of +2 will just be 4. 2 to the power of 4 gives us 16, which goes right off our chart. So we really are ready to start. 1/16 is a very, very small value, right? When we go to -2, a quarter is still quite small. At 0, we're at the value of 1. At 2, we're at the value of 4, and 4 is way off the chart. 3 would give us 2, 4, 8. So let's actually add that into here. Okay, so we're essentially doing something like this for our 2 to the power of x. Okay, so with that being said, we could kind of go through all of these ideas, and maybe it might be best if we work with our stretches, our vertical stretches and our horizontal compressions to start. Okay. And mapping notation helps out a lot with that. And the way we can use mapping notation is once we have our values, so once we have our coordinates, which we essentially have here, we can put them into almost like an equation, right? So for our x value, your equations would read a times, oh, sorry, no, those are y values. Let's talk about what affects the x. X values deal with horizontal stuff, so that means our k or our d, right? So that means our x value is technically divided by k, okay? And so x over k plus d, and we get our y value, which is y times a plus c. Oops, let's put it down. So they're both plus, which is important, because had we written a negative, it would have given us the opposite translation. So let's scroll down here. I've moved our coordinates, and we're going to put them through, and that should say plus. I'm going to put them through this mapping notation. So we'll build it once again with our x value. Our x should be divided by k. Our k value was 2. And because it's plus d, so this is where it gets confusing. Because it's technically moved 3 units left, that's like the value of -3. Think of that as what our d value is. When we plug it into our equation, because it's x minus -3, it becomes a plus. But here, because it's plus d, it becomes a subtraction, so -3. And then our a value was -2, so -2 times y. And our c value we added, so because it's -1, we subtract -1. So now we plug these values in quickly here. -4 divided 2 is -2, -3 is -5. Okay, and we've already done this part, or I already did this part very quickly. This actually ends up being -9 over 8. Okay, our y value, plug 1/16 in, you multiply by -2, becomes -1/8 minus 8 over 8, 9 over 8. Let's plug in -2. If we plug -2 in, that becomes -1 minus 3, which is our -4. Okay, and our y value, we plug in a fourth. Whoops. That becomes -1/2 minus 1 is the same as -3 over 2. I should have wrote it last time. So -3 over 2. 0 over 2 is 0 minus 3. So we get -3. So you notice a pattern, our x's are all going or increasing by 1. We plug in our value of 1. 1 times 2 is -2 minus 1 is -3. -3. We plug in 2, becomes +1, -2, 4, -1. I just wanted to keep it that pattern. And 4, this becomes 4 times -2 is -8 minus 1, -9. And then finally, the last one, 16. If you plug in 16, that becomes -32 minus 1, -33 is our value. Great. Okay. So we plot our points. 5, -9 over 8. Or sorry, -5. So we'll use our corresponding red point here. -5, -9 over 8 is like very, very close to -1. Our green coordinate, so I'll kind of highlight them here. That was our red. This will be our green coordinate. -4, -3 over 2. So -4, -3 over 2 is -1.5-ish. So about there. Our blue coordinate, okay, so that's kind of corresponding to this one here, is -3, -3. That works out really nice. And next one we'll do, what color did I do it in? Oh, orange. Our orange coordinate here, -2, -9, so that's referring to the 2, 4. And then the other coordinate after that won't even fit on our page, obviously. So here is our translation of that exponential function.
It makes sense.
Yeah, and it's been shifted to left. And we can double check it with kind of our graphing program here. And the very first coordinate, I'll zoom in a little. One of the coordinates was -2 and 1 over 4, I think it was. And it translates to this one here. Okay, so you can see that it's been moved 3 to the left, then shifted down 1 unit, and then vertically stretched pulls it in, and horizontal stretch pulls it in also again. Okay.